Welcome to the TOEFL Listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Dr. Morales. Thank you for meeting me during office hours about my concert hall project.
Good afternoon, Michael. Please sit down. Tell me which acoustic principles you want to focus on.
I want to concentrate on sound reflection and absorption for optimal acoustics and how to balance them for symphonic and chamber music.
That is a central issue for concert hall design. Balancing reverberation and clarity is critical.
Exactly. I have been reading about reverberation time, commonly called RT60, and how it affects warmth and clarity.
Yes, RT60 is the time it takes sound to decay by 60 decibels, and for symphonic music, you generally aim for a value around 1.8 to 2.2 seconds, depending on hall volume.
So longer RT60 gives more warmth but reduces clarity, is that correct?
In broad terms, yes, longer reverberation adds sustain and a sense of blend, but too long, and individual articulation is lost, especially in fast passages.
How do early reflections factor into clarity and spatial impression?
Early reflections arriving within roughly 80 milliseconds reinforce direct sound and enhance clarity and the sense of envelopment.
Is lateral reflection particularly important for a sense of intimacy?
Lateral reflections are crucial. They provide lateral energy to the listener, which increases perceived spaciousness and listener envelopment.
I read about the shoebox design, like the Vienna Musikverein, and the vineyard terrace design, like the Berlin Philharmonie. Which one gives better lateral reflections?
Shoebox halls tend to produce strong lateral reflections from parallel side walls and a narrow width which contributes to the celebrated warmth of the Musikverein.
In the vineyard design,
vineyard terracing surrounds the stage with irregular terraces, which scatter sound and can produce diffuse reflections that give clarity and evenness across seats.
So the geometry decides initial reflection patterns, and the materials adjust absorption and diffusion.
Precisely, geometry creates the paths and materials change. How much energy is reflected or absorbed at each surface?
What materials are typical for reflective surfaces in halls?
Hard, dense materials like certain woods and plasters are used for specular reflection, while convex surfaces and wood diffusers scatter sound to avoid strong echoes.
And absorptive materials are used to control excessive reverberation.
Exactly, heavy curtains and upholstered seats absorb mid to high frequencies, while porous absorbers and bass traps handle low-frequency energy, which otherwise creates boominess.
How do designers manage the need for different acoustics for orchestra and spoken word?
Many halls incorporate variable acoustics such as movable banners, curtains, and adjustable ceiling reflectors or canopies to alter absorption and the effective volume.
That makes sense, so you can shorten RT60 for amplified speech and lengthen it for symphonic performance.
Yes, you can tune the hall this way and also change early reflection patterns by moving overhead reflectors.
Are there common problems like echoes or flutter that I should avoid in my designs?
Flutter echo occurs between parallel surfaces. It is a series of rapid reflections that can be controlled by angling surfaces or adding diffusion.
So angled walls and scattering panels help to break up standing wave patterns and flutter.
Yes, and you should also pay attention to low-frequency modes, which are affected by room dimensions and volume.
Would it be reasonable to include numerical targets like RT60 and a clarity index in my design brief?
Absolutely include targets such as RT60 in a given frequency band and clarity measures like C80, which quantify early to late energy balance.
Could you give me concrete examples to cite from existing halls?
Cite the Musikverein as an example of successful shoebox geometry with rich lateral reflections and a moderate RT60 for symphony.
And the Berlin Philharmonie for its vineyard terraces and canopy reflectors.
Yes. The Berlin Philharmonie uses an irregular terraced layout and suspended reflector panels to distribute early reflections more evenly.
When designing seating, what acoustic role do the seats themselves play?
Seats contribute significant absorption when unoccupied, so designers test with occupied and unoccupied conditions and use seat designs with absorption properties similar to a seated person.
I see we must simulate both conditions to get realistic RT60 estimates.
Correct and measurements or auralization tools help validate your model.
How about stage design and the orchestra shell?
A well-designed stage shell directs sound toward the audience and provides early reflections for the musicians to hear each other, which improves ensemble and projection.
Would adjustable shell panels be part of variable acoustics?
Yes. Movable shell panels and overhead reflectors are common tools to tune both musician monitoring and audience experience.
For my project, I am thinking of combining a shoebox base with adjustable reflectors and modular absorptive banners.
That is a sensible hybrid approach. It preserves the beneficial lateral reflections of a narrow hall while allowing tuning for different repertoire.
I will include numerical targets, describe materials, and propose movable elements, then run a simulation and an auralization.
Good plan. Be sure to justify choices with examples and to explain how early reflections and absorption interact to shape clarity and warmth.
Also, I asked whether we should add adjustable banners because they help control reverberation time during different performances.
Yes. Include that line in your conclusions and explain the trade-offs between absorption and lateral energy so your committee understands the reasoning.
Thank you, Dr. Morales. I will draft the section on reflection patterns, absorption coefficients, and variable systems, and bring it next week.
You are welcome, Michael the First. Look forward to reviewing your acoustic targets and simulations next week.
Listen again to part of the conversation. Then answer the question.
I asked whether we should add adjustable banners because they help control reverberation time during different performances.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.